Hello everyone, this is Chandana Saishri from JNTU College of Engineering, Anantapur. Let's discuss about Introduction to Linear Data Structures. Data structures are classified into two types, linear and non-linear. Here we are discussing about linear data structures. Linear data structures are data structures that organize data elements in a sequential manner. Elements are stored in a linear order with each element connected to its previous and next element. Common linear data structures include arrays, linked lists, stacks, and queues. Arrays. An array is an object that holds a fixed number of values of homogeneous or similar data type elements. Elements in an array can be accessed using their index position. Arrays have a fixed size and require contiguous memory allocation. Linked lists. Linked lists are linear data structures composed of nodes that store data and a reference to the next node in the sequence. Linked lists do not require contiguous memory allocation, allowing for dynamic memory management. That means linked list does not need any particular value that define the size of the list. It can be allocated any number of nodes. Common types of linked lists include singly linked list, doubly linked list, and circular linked list. Stacks. Stacks are linear data structures that follow the last in first out principle. Elements are added and removed from the top of the stack, making it a simple and efficient data structure for certain operations. Operations performed in stack like insertion or deletion are known as push and pop. Queues. Queues are linear data structures that follow the first in first out principle. Elements are added at the rear and removed from the front of the queue. Addition of the element is known as enqueue and removal of an element is known as dequeue in queue operations. Queues are commonly used in scheduling algorithms, breadth first search, and data buffering. Applications of linear data structures. Linear data structures are widely used in various applications such as data storage, algorithm design, and system implementation. Arrays are used for efficient data retrieval and manipulation. Linked lists are used in dynamic memory allocation and recursive algorithms. Real-life examples of stacks. Examples of stacks in real life include the call stack in programming languages where function calls are managed. Another example is the undo feature in text editors where previous actions are stored and can be undone in reverse order. Stacks are also used in browser history for navigating back and forth between web pages. Real-life examples of queues. Examples of queues in real life include waiting lines at a bank or supermarket where customers are served in the order they arrived. Task scheduling in operating systems uses queues to prioritize and execute processes. Complexity analysis of linear data structure. The time complexity of common operations on linear data structures varies based on the implementation. Arrays offer order of 1 constant time access for element retrieval, while linked lists provide order of n linear time access. Stacks and queues typically have order of 1 time complexity for push, pop, enqueue, and dequeue operations. Advantages of linear data structures. Linear data structures provide efficient memory management and flexible data organization. Arrays offer constant time access for element retrieval and are suitable for random access patterns. Linked lists allow for dynamic memory allocation and efficient insertions and deletions. Challenges of linear data structures. Linear data structures may have limitations in terms of memory overhead and access times for certain operations. Arrays have a fixed size and may require resizing to accommodate additional elements. Linked lists can incur additional memory overhead due to the storage of node pointers. Comparing linear data structures. Arrays are efficient for random access and have a fixed size, while linked lists offer dynamic memory management and flexible information insertions and deletions. Stacks queues are specialized linear data structures with specific access patterns like LIFO for stacks and FIFO for queues. Let's come to the summary of the video. Linear data structures organize data elements in a sequential manner with each element connected to its previous and next element. Common linear data structures include arrays, linked lists, stacks, and queues, each with unique characteristics and operations. Here, operations means like push, pop, insertion, deletion, enqueue, dequeue, traversal, display, etc. Understanding the fundamentals of linear data structures is essential for effective algorithm design and system implementation. Sequential organization. In computer science, sequential access means that a group of elements is accessed in a predetermined order sequence. Sequential access is sometimes the only way of accessing the data. For example, if it is on a tape. Let us take this example. See, if we access if the elements are inserted in the sequential way, then it will be very easy for us to access, whereas we can see how complicated it is to access an element in randomly allocated element.